Series formation we are starting today. So first we will discuss about the theory of series formation. Normally series sequence in competitive exam perspective means the same. Mathematically they are different because sequence, that sum of terms of a sequence is called series, but mathematically when you see series and sequence almost they mean the same in a competitive exam perspective. So in a question if you see what is the next term in the series, what is the next term in the sequence, think that they mean the same. So normally a sequence or series, as I told, if I use the term series or sequence, don't get confused. I am meaning the sequence, mathematical sequence itself is what I am meaning. So a sequence can be categorized into number sequence, letter sequence and symbol sequence. And in this the most important one or the most number of questions came from number sequence or number series. So we will discuss that in detail today. Number sequence, what all are the types of it and how to identify them, that is the topic of today. These are the major number sequence you should remember. Means that these are the only sequences that are there. There are many sequences other than this also, but these are called standard sequences. These are the sequence, if it comes we can just directly say the next value by identify them. But there are some non-standard sequence which can have any rule, that a into b minus 3, a into b plus 3 or a into b minus 2c. So that is called non-standard sequence. That if time allows today we will start, otherwise tomorrow we will discuss that. Anyway, we will start standard numbers sequence. These are the 11 major types. From the name itself you can understand most of them. You can go through this flashcard to understand it better. I will explain one by one so that you get more practice on this. So these sequences we are going to elaborate. First of all, we will go for the 4 of these sequences. First one is arithmetic, then geometric, then prime, then power. Because from that 4 sequences you can make the other 5 sequences. So first we will discuss arithmetic sequence, geometric sequence, prime sequence and power sequence. Arithmetic sequence, as you can guess, is a sequence of arithmetic progression. A sequence which satisfies an arithmetic progression is called an arithmetic sequence. Arithmetic progression you all know. In case you have forgotten, arithmetic progression means a common difference should be there. For example, 3, 7, 4 difference, 7, 11, 4 difference, 11, 15, 4 difference. So the next term will be 19. You can post in the chat box also what is the next term you are getting. So that is a very simple arithmetic sequence. One more example, 1, 6, 11, 16 next term. Most of the time question will be asking find the next term or the missing term or what is the wrong term. These are the 3 type of problem which can come from this topic. So 5 difference, 5 difference, 5 difference, because 1 plus 5 is 6, 6 plus 5 is 11, 11 plus 5 is 16. So 16 plus 5, 21 will be the next term. So plus 5 is the idea there. But all the time it may not be positive difference. Depending upon the difference there can be 3 type of arithmetic sequence. Arithmetic sequence with positive difference, arithmetic sequence with negative difference, arithmetic sequence with decimal or fraction difference. So I will show you an example. Very simple things, but I am just summarizing it so that you will not miss it at the time of exam. You can pinpoint to the particular sequence as soon as possible. That is why I am elaborating very obvious things also. So 10, 8, 6, 4, what is the next term? Here it is minus 2, 10 plus minus 2, 8 plus minus 2, 6 plus minus 2. So 4 plus minus 2, 2 will be the next term. So it is subtracting, or we can say negative number is added. Now the adding number can be a decimal value or a fraction value also. 2.3 plus 0.3 is 2.6. 2.6 plus 0.3 is 2.9. 2.9 plus 0.3 is 3.2. So 0.3 is added, or we can say in monetary terms, you can say it is 30 paise is added. 30 paise is added. That way also arithmetic sequence can come. Now the best way to learn sequences, try to make your own sequence. Try to make your own sequence, because once you make your own sequence you will not forget the concept. That is what I can say. So how you can make your own sequence? To make an arithmetic sequence, what you need? To make an arithmetic sequence you need a common term or a first term and a common difference. For example, if you fix 10, and if you fix that the common term you are adding is 7, so 10 plus 7 17, 17 plus 7 24, 24 plus 7 31, and so on. So to create an arithmetic sequence, you just want to fix a first term and add the common difference. You can fix that common difference also, and according to what difference it is, you can find next terms or find more examples. So always keep in mind, every chapter have a particular way of teaching also, a particular way of learning also. Series formation or sequence formation, the best way to learn is try to create your own examples. Don't only practice previous year questions, you can create your own examples and find the next term. So that will be a good exercise. If you people want, in the WhatsApp group you can make a question and give it for your friends or give it for your other group members to try, so that there will be a healthy discussion happening in the group also. So arithmetic sequence is clear, I guess. Then more examples for arithmetic sequence are given here. I will tell you, if possible, try to find the next term in all these sequences and find it as soon as possible. That is the important thing. These topics are very simple, but the only thing is the speed in which you are doing that questions. 12, 19, 26, 33. When it is told arithmetic sequence, it cannot be more simple than that. So you just have to see the difference and see what is that difference. 7 difference, 7 difference, 7 difference. So 40 should be the next term. Next it is minus 4 difference. Minus 4 is the number you are adding with. So minus 4 will be giving you next term 1. One more term means minus 3. Here also minus 5. Very obvious. So 25. 0.5. 0.5 is added. Again, if anyone have difficulty in adding decimals fast, I will tell you, try to think in terms of money, because our brain have a better ability to process money than numbers, because that is normally we see numbers daily, na? So 3.6 you can think like 3 rupees 60 paise, 4.1 is 4 rupee 10 paise, 4.6 is 4 rupees 60 paise. So the difference between them is 50 paise. So 5.1 plus 50 paise, 5.6, that is 5 rupees 60 paise. That is the next term. Next example is 0.05 negative difference. 0.05 is subtracted. 0.05 means monetary perspective, if you think, it is 5 paise. 5 paise, 5 paise, 5 paise. Sorry, it is a plus 0.05 itself. Sorry, it is not minus, it is plus 0.05 itself. So 5 paise is added. So be very careful. 5.05 plus 5 paise is 5.10, not 5.01. It is 5.10. I am sure that all of you are clear about it. 5.1 will be the answer. So if that is clear, let's go to the next sequence. Next is geometric sequence. From the name again you can guess what is geometric sequence. A sequence which follows geometric progression. If you have forgotten what is geometric progression, there is a common number multiplied to get the next number. That means first number into a common number you will get next number. That next number into the same common number, if you multiply you will get the third number, and so on. Look at the first example. 3, 6, 12, 24. 3 into something is 6. 3 into 2 is 6. 6 into 2 is 12. 12 into 2 is 24. So 24 into 2, 48 will be the next term. So that is the idea. Into 2. Now depending upon what common term is multiplied, you can divide geometric sequence also into 3. Geometric sequence with positive ratio. This is called ratio. 6 by 3 is 2. 12 by 6 is 2. Because if it is difficult, you have to identify the ratio by dividing itself. 6 by 3, second by first number, third by second number, fourth by third number. You will get the 2 easily. But here you can, by observation itself, you can find 2. That is why we don't divide it. Anyway, that is called common ratio. So next term will be 9 to 6. So anyway, I was telling that the common ratio can be negative also. The number you are multiplying common with can be negative also. For example, second example, 10 minus 40, 160 minus 640. What is the common ratio? Minus 4 is a common ratio, because into minus 4 you will get minus 40. Into minus 4 you will get 160. Into minus 4 you will get minus 640, because minus will go plus minus, because 10 into minus 4 minus 40. Minus into minus will make it positive. Now that is why 160. So minus 640 into minus 4 will be the next term, that is 2560 will be the next term. So you can have a negative ratio also. Now the ratio can be fraction. Ratio can be fraction means, look at the third example. 2048, 1024, 512, 256, 128. Half you are multiplying with. Half into half. 2048 into half is 1024. 1024 into half is 512. 512 into half is 256. 256 into half is 128. So the next term will be 128 into half. Or simply speaking, take the half of the number to get the next number. So depending upon the ratio, it can be positive, negative or fraction. I think that is also very obvious. Let's go to the next slide where it have 5 more examples. All of you go through the 5 examples. 2 into 2 into 2. So definitely 160 will be the next term. Very obvious. Here into minus 3, into minus 3, into minus 3. So next term will be into minus 3. Minus into minus plus. So it is plus 243. Into minus 4, into minus 4, into minus 4. So it should be into minus 4. Minus 320 into minus 4. Minus minus plus 32, 32, 64, double 1280. These kinds of multiplication, if you have any confusion or if you think that it is taking more time, I will try to give you some ideas in Vedic mathematics how to do multiplication fast. Even very big number you can do very easy multiplication or Mendel multiplication. I will try to give you some idea because in CSIR-NET exam calculators are not allowed. In this 50 lecture course I will try to add some lectures which is giving you idea about Mendel arithmetic or Vedic math, how to do squaring, how to do cubing, how to do square rooting, how to do cube rooting, because that may help you in your subject part also. So anyway, next term 400, 200. 400 into half is 200. 200 into half is 100. 100 into half is 50. 50 into half is 25. So into half 12.5 will be the next term. Now the last thing, it is little difficult to find. This was a previous NET exam problem. We will discuss that in detail when we discuss the previous year questions. Second term by first term, 640 by 1024 when you divide, you will get 5 by 8 finally as the ratio. 400 by 640, third term by second term if you divide, you will get 5 by 8 itself. You can check it. 250 by 400. By directly looking at the terms, if you are not able to understand what is the common ratio, you have to divide it like this and understand. This is also 5 by 8. That is how we get the idea that 5 by 8 is the number you are multiplying. Yeah, try to keep the order second by first, third by second, fourth by third, rather than first by second, second by third, third by fourth. Because first by second, second by third, third by fourth, then the ratio will be 8 by 5. Then it is not into 8 by 5, then it will be divided by 8 by 5. That is why it is always better to go with the order. First value, second value, third value, fourth value means second by first, third by second, fourth by third and so on. Anyway, 5 by 8 is a common ratio we understood. 5 by 8 multiplied you will get 156.25. Yeah, you may be thinking that that is little difficult to multiply and all. If so, don't worry, by the answer options given in that previous year NET exam problem, you could have easily done that question. So I will explain that when we discuss the previous year questions. So that is about geometric sequence. Now the next sequence is prime sequence. From the name itself, it is very obvious. Prime sequence is a sequence of prime numbers. And I hope all of you know what is a prime number. Otherwise, read the definition given here in case you have forgotten any of your school math. Prime numbers are numbers which can be exactly divisible by 1 and that number only. That means for prime numbers, 1 and that number only should be factors. So what will be prime sequence then? Sequence of ordered prime numbers will be prime sequence. For example, 7, 11, 13, 17, 19. From 7, continuous prime numbers are written. I am sure that all of you are clear. These are prime numbers and these are consecutive prime numbers. That means next prime numbers. So next prime number after 19 will be the next term. If the question was asking what is the next term, next prime number after 19 is 23. So 23 is the next term. Now one more example. So prime sequence, the only variety that can come is according to the first term you are starting. If you are starting with 29, that is another example. 43 next prime number will be the answer. 47 will be the next prime number. So I think prime sequence you understood. Normally prime sequence will be given in ordered set only, not like one prime number after that 10 prime numbers later next prime number. No, that will be then very confusing. So normally prime sequence will be given in the order only. Why I am saying this is I am analyzing all the previous year question papers of CSIR-NET Part A section. From that I am telling how CSIR normally set the question paper. I am trying to stick on to CSIR-NET exact syllabus so that it will be easy for you to learn and it will be easy for you to score more mark by the minimum practice. So power sequence, next is power sequence. Sequence of consecutive powers are called power sequence. Powers means what? Squares, cubes, fourth powers, etc. So according to which power you are taking, you can categorize it again. Square sequence means sequence of consecutive squares. Sequence of consecutive squares means, look at this example, 2 square this is 3 square, 4 square, 5 square, 6 square. So the next term will be 49 because the next square is 7 square. Then cube sequence is also possible. Consecutive cubes, this is 3 cube, this is 4 cube, this is 5 cube, this is 6 cube, this is 7 cube. So 8 cube should be the answer. 8 cube is 512 and so on. Yeah, you may be thinking that higher cubes are difficult to find. So if they ask, what you will do? Normally till now they have asked till square sequence only. So learning till square sequence itself is fine. Otherwise I will teach you some techniques to find the cube of any number till 100. That I will discuss in another class. So power sequence can be fourth power also, but for CSIR-NET perspective, fourth powers and all will not come. In my opinion, try to concentrate more on square sequence itself. Square sequence they can twist it in different way. Square sequence they can write alternative squares also. For example, if they write 9, 25, 49, 81, etc., that is also a square sequence but not ordered pair. That is alternative squares, 3 square, 5 square, 7 square, 9 square. So the answer will be what? 121, 11 square, 121 will be the answer. This is 3 square, this is 5 square, this is 7 square, this is 9 square, so 11 square will be the answer. Or squares of prime numbers is possible, combination of prime and power. Those all are possible, that is another genre. So I will explain that non-standard sequence or derived sequence we can see. This is fundamental sequence or basic sequence I am explaining now. After that I will give you varieties of that. So power sequence also I think all of you got the idea. Why I am saying this name by name? Because these are the sequence you can fundamentally test in your question paper. If this comes, you can easily do that way. So these are the 4 sequences we learned. Now from this sequence we can form 5 more sequences. That is what I am teaching. 4 sequences, I think all of you understood. This one, this one, this one, this one. More examples are given here. You can go through it. Now from those 4 sequences you can form arithmetic-o-geometric, geometric-o-arithmetic, 2-tier sequence, reversal sequence and twin sequence. I will explain one by one. Arithmetic-o-geometric, from the name you can guess what is it. Arithmetic-o-geometric means it is the combination of arithmetic sequence and geometric sequence. Look at this example, you will get a clarity. Look at this example. Combination of arithmetic and geometric means, simply speaking, those of you are good at math, with this simple formula you will understand. X plus A into B will be the standard form of an arithmetic-o-geometric sequence. A common number is added, then multiplied by a common number, because adding common number is called arithmetic sequence, multiplying common number is called geometric sequence. So combination of these two will be arithmetic-o-geometric sequence. I will elaborate with the example. If I am taking 2 as the first term, 2 plus 2 is 4, 4 into 3 is what? 12. That is how the next term 12 came. Now with the same rule you have to apply to get 42. 12 plus 2 into 3. Plus 2 is 14, 14 into 3 is 42. That is how the next term 42 came. So I think you understood the idea. X plus A into B, what does that mean? A common number should be added and a common number should be multiplied. Here that common one number was 2 and 3 respectively. Adding common number is 2, multiplying common number is 3. That is how you got 12 and 42. So from 42 get 132 also. Let's see whether it is correct. 42 plus 2, 44. 44 into 3 is exactly 132. 132 plus 2, 134. 134 into 2, 3 is exactly 402. So to find the missing term, I think all of you got the idea. Mention the answers then. 402 plus 2, 404. 404 into 3 will be the answer. That is 1212 will be the answer. A common number added, then multiplied by a common number. As I told earlier, the best way to learn a sequence is try to create examples. Arithmetic sequence, arithmetic geometric, if it is troubling you, try to create an example yourself. How you can create an example? X plus A into B. Fix an A, fix a B. And fix an X also. That means a starting term. For example, I am taking 10 as the starting term. And the number you want to add, I am just thinking that let 3 be the common number you want to make. So the first term is 10. For my example, first term is 10. 10 plus 3 into B. Into B, let it be 3. Because if the number is big, it will be difficult to find. 13 into 3, 26. Now, same thing apply. 26 plus 3. 26 plus 3 into 2. 26 plus 3 is 29. 29 into 2 is 58. So, next term is 58. 58 plus 3, 61. 61 into 2, 122 and so on. As I told, if you want to master this topic, the best way to do is try to create your own examples. Because when you hear the sequence, it looks like every sequence is simple. But at the time of competitive exam, the problem is you will not be given what is a sequence. You will not be asked, this is an arithmetic sequence, this is an arithmetic or geometric sequence. Can you find the next term for us? No, CSIR will not ask a question like that. Question will be only asking what is a next term, what is a missing term, or what is a wrong term. There, from the pool of infinitely many sequences, you have to pinpoint to the sequence you want. That is a challenge you are having in CSIR-NET exam also, or in any competitive exam. So, practicing more, using techniques like this, creating your own examples, that is the only way to master it. Otherwise also you may get the answer. I am not saying that you may not get the answer. But maybe after 2 minutes or maybe after 1.5 minutes, you could have easily got that answer in less than 1 minute. The time factor is very important. In previous classes also I told you the time factor. More than 2 minutes you should not do for any question. But these are some of the questions which can be done in less than 1 minute also. So if arithmetic or geometric, if you understood, let's go for geometric or arithmetic. Now you can clearly guess what is geometric or arithmetic. Arithmetic or geometric, a common number was added, then multiplied by common number. Here a common number is multiplied because geometric is first, then added by a common number. That is geometric or arithmetic sequence. For example, 3 into 2, common number multiplied, that is not 6, that is not 7. 3 into 2 plus 1 is 7, plus 1 is 7. So we understood that a common number 2 is multiplied, common number 1 is added. But that should satisfy second term also. This 7 into 2, 14 plus 1 should be the next term, 15. Yeah, that is also satisfying. That 15 into 2, 30 plus 1, 31. That is the next term. That is also satisfying. 31 into 2, 62 plus 1, 63. That is the next term. That is also satisfying. So we are confirmed that this is a geometric or arithmetic sequence. Once we are confirmed about it, you have to find the next term by the same idea. What is the idea? Into 2 plus 1. Into 2 plus 1 is the common idea we derived. So 63 into 2, 126 plus 1, 127 will be the next term. If the question is asking next term of this sequence, 127 will be the answer. So the best way to learn this sequence also, create an example yourself please. All of you try it. All of you try to create an example. I will help you out if you want. You need a first term. Fix any first term you like. I am fixing 5. You can fix it 6. You can fix it 7. You can fix it any first number you want. Now you want to multiply with a common number. What number you are multiplying with? You can multiply with 2 into 2, 10 then add it with 3. You can decide into 2 plus 3 is the common rule you are applying. Into 2, 10, 10 plus 3, 13. Then 13 into 2, 26, 26 plus 3, 29. 29 plus 29 into 2, 58. 58 plus 3, 61. Are you getting the point? 61 into 2, 122. 122 plus 3, 125 and so on. So that is geometric or arithmetic sequence. Create as many examples as possible so that you won't forget this sequence and you don't forget to check the sequence at the time of exam. Let me tell you one more consoling thing. Arithmetic or geometric, geometric or arithmetic in NET exams it was not asked. In GATE exams it was asked. But we can't say it won't be asked because arithmetic sequence, geometric sequence was asked. Combination of them can be asked. I am trying to give you all the perspectives. So arithmetic or geometric, geometric or arithmetic, I think you got the idea. Now arithmetic, geometric, prime and power, with that sequence we can form more sequences. Reversal sequence, two-tier sequence, twin sequence are some of the examples of it. Reversal, two-tier, twin sequences. Reversal sequence, what is it? Again, from the name you can guess what it is. Reversal sequence is a sequence where reversing the terms you will get another sequence. Look at this example, you will get an idea. I am giving these names just to make you understand or just to make you remember what the sequence is. Reversal sequence, let's see how it works here. 71, if you reverse the terms, reverse the digits we can say. 71 reversed is 17. 02 reversed is 20. 32 reversed is 23. 62 reversed is 26. 92 reversed is 29 and so on. Are you all understanding? And what are they? They are an arithmetic sequence. 3 different arithmetic sequence. So 29 plus 3, 32 will be the next term in that. But the answer is not 32. 32's reverse of digits will be the answer. 23 will be the answer. So this is a sequence which can be obtained only by reversing the digits. I think that is also clear to all of you. But that reversing can be done on an arithmetic sequence also. In this example, this is a reversal arithmetic sequence because an arithmetic sequence is reversed. Now, it can be reversed on a geometric also. It can be reversed on a prime sequence also. It can be reversed on a power sequence also. The sequence which I have taught till now, that 4 sequences can be reversed in the same fashion. So, look at the second example I have given. What is reversed? How you know? By reversing you know. 61 reversed is 16, 52 reversed is 25, 63 reversed is 36, 94 reversed is 49, 46 reversed is 64, 81 reversed is 18 reversed is 81. Look at this. 4 square, 5 square, 6 square, 7 square, 8 square, 9 square. So the next term should be 10 square 100. 100 is not the answer. 100 reverse should be the answer. 0, 0, 1 should be the answer. So we can say this is an example of a reversal power sequence. What is power sequence? We understood. Reversing that you are getting reversal power sequence. One more example. Look at this example what they are. Under the title reversal sequence, it is so simple, na? You just have to reverse it. But the unfortunate thing is at the time of exam, you will not be told that this is a reversal sequence. That is what I told, that is a skill you should develop by practicing more and more questions, by creating your own examples. So to create a reversal sequence, what is the requirement you have? You have to create first an arithmetic sequence or a power sequence or a prime sequence or a geometric sequence. Then reverse the digits. That's all. So third example, what is this? 400, 200, 150 is geometric sequence with a common ratio half into half, or we can say divided by 2. So into half means next term should be into half 25. 25 is not the answer because 25 reverse 52 is the answer. So we can say this is a typical example of a reversal geometric sequence. Reversal geometric sequence. I think you have understood this. Now you can have two-tier sequence. Two-tier sequence, listen very carefully what is a two-tier sequence. Two-tier sequence means the difference will follow another sequence. The difference will follow another sequence is called two-tier sequence. Difference will follow another sequence means what? First term and second term sequence will be having a difference, second, third difference, third, fourth difference, fifth, sixth difference. That difference, if you form a set, that set will be any of the sequence we already learned: arithmetic, geometric, prime, power, etc. Let's see first example. 1, 4, 10, 19, 3. 1 and 4 difference 3. 4 and 10 difference 6. You have to take the difference, then only you will understand what is the sequence that is hidden inside it. So 12 is the difference. 3, 6, 9, 12 means that is an arithmetic, simple arithmetic sequence. Now, so after 12 comes 15. So the difference between 31 and the next term should be 31 plus 15, 46 will be the next term. If x is the number, x minus 31 will be 15. That is what we understood. Next difference should be 18. So it will be 64 and so on. So here we can say this is a typical example of a two-tier arithmetic sequence. So if two-tier arithmetic exists, two-tier geometric also can exist. Now, two-tier prime sequence also can exist. Two-tier power sequence also can exist. So try to create your own example and try the second example what it is. How to identify a two-tier sequence? Take the difference, that's all. 7 difference, 11 difference, 13 difference, 17 difference. 7, 11, 13, 17. Observe it carefully. 4 difference, sorry, it is not a arithmetic sequence, it's a prime sequence. 7, next prime 11, next prime 13, next prime 17. So next prime is 19, that means next difference should be 19. 53 and the next term's difference should be 19, or 53 plus 19 will be the next term. 53 plus 19 is 72, so 72 will be the next term. So we can say second one is a clear example of a two-tier prime sequence. Two-tier arithmetic, two-tier prime, two-tier power, two-tier geometric, all are possible. Third example, look at it. 3 difference, 6 difference, 12 difference, 24 difference. 3, 6, 12, 24 is another sequence. What are they? Geometric sequence. Common ratio 2. So 48 should be the next difference between 47 and next term. 47 plus 48, 95 will be the next term. So two-tier geometric sequence. I haven't written two-tier power sequence example, but you can create your own, and there was a previous NET exam problem exactly asking an example of a two-tier power sequence. Two-tier prime sequence was also there in another NET exam. So these are questions that have asked in multiple exams. So two-tier sequence, I think all of you understood. So what is a simple trick to identify two-tier sequence? Take the difference of successive terms. Now twin sequence. What is twin sequence? From the name twin itself you will understand what is twin sequence. Two sequence twinned into one like this. Two sequence twinned into one. That means there will be two sequence, or simply speaking, in the odd numbered positions one sequence will be there. In even numbered position there will be another sequence. Odd numbered position means first term, third term, fifth term, sixth term, seventh term, ninth term. The position I am referring to, that will be one sequence, and second term, fourth term, fifth, sixth term, eighth term, etc. will be another sequence. I will show you an example to understand it clearly. 1, 0, 6, 3, 11, 6, 16. When you look at first you will not understand a sequence, but when you take it out it is very simple a sequence. 1, 6, 11, 16, that is an arithmetic sequence with a common difference 5. 5 is added. And 0, 3, 6 is another arithmetic sequence with a common difference 3. So two sequence twinned into one. So plus 3, 6 plus 3, 9 will be the next term. One more term if you want, 16 plus 5, 21 will be the next term. So this way also question can be asked. Here we can say one arithmetic and another arithmetic is twinned into one. Two arithmetic sequence are twinned. Here we can have many combinations. Arithmetic and geometric can be twinned. Arithmetic and prime can be twinned. Arithmetic and power can be twinned. Geometric and power can be twinned. Geometric and prime can be twinned. Prime and power can be twinned. All these are possible. Look at the second example. 3, 6, 12, 24. It's a geometric sequence with a common ratio 2. 3 into 2, 6 into 2, 12 into 2, 24 into 2. So 48 should be the next term here, because the other sequence is another sequence 1, 4, 7, 10, which is an arithmetic sequence with the common difference 3 plus 3. So this is a typical example. A arithmetic sequence and a geometric sequence is twinned into one. Arithmetic, geometric, twinned into one. I think that is also very clear now. So we can create more examples of twin sequence. What you need for that? You just have to take what we can say, create one sequence, create an arithmetic sequence, or create a geometric sequence, then a prime sequence or a power sequence, twin it into one. Write one term in one sequence. For example, if you are creating 10, 17, 24, 31, etc., that is one sequence you are creating. Another sequence is 17, 19, 23, 29, etc., prime sequence. So to twin it, what you need? 10 you write, then 17 you write, then 17 you write, then 19 you write, then 24 you write, and so on. 23 you write, and so on. That is called a twin sequence. So try to create your own examples. Let's go to another sequence, which is a mathematical sequence, called Fibonacci sequence, which you have heard, I guess. Fibonacci sequence or Fibonacci sequence. It is actually a very interesting sequence because that is seen in the nature also. If you have seen the Super 30 movie, you may have seen the explanation of Fibonacci sequence and other sequences in nature, about the explanation of golden ratio. Golden ratio is actually the ratio of the terms of the Fibonacci sequence itself. There are many applications in nature. Fibonacci sequence also, golden ratio also have. I will tell you that if possible, try to Google about Fibonacci sequence and its applications in nature. It will be very interesting to know. Anyway, due to lack of time, I will stick on to Fibonacci sequence. Fibonacci sequence, this is the definition. First two terms should be 1. It cannot be anything else. It should be 1. And each subsequent term is the sum of the previous two terms. What does that mean? Third term should be the sum of first two terms. That means this 1 and 1 added will be this 2. This 1 and 2 added is this 3. This 2 and 3 added will be this 5. This 3 and 5 added is this 8. 5 and 8 added is 13. 8 and 13 added is 21. So definitely next term will be what? 13 and 21 added 34. 21 and 34 added 55 and so on. So that is called Fibonacci sequence. I think all of you are clear, and there was a previous NET exam which was asking exactly the sequence, Fibonacci sequence. So now I want to teach you one more sequence, that is called see and tell sequence. This was asked in a previous NET exam, that's why I don't want to skip this topic. What is see and tell sequence? Listen very carefully. What is see and tell sequence? From the name itself you can guess what it is. See the sequence and tell the sequence, you will find the next term. It will take some time to understand this. With more examples I will elaborate. It's a very standard or very famous sequence. Watch and say sequence is another name for this. So see and tell sequence means, like you say mobile number. Yeah, can anyone guess what is the next number? You can post in the chat if you want. This was similar to a previous NET exam problem. I will show you that problem also after this, but just try what will be the next term in the sequence. By looking at the sequence, you can be sure that this is not any of our normal sequence, because normal sequence, this much big exponential growth chances are very rare. Because 2 is becoming 12, then 12 is becoming a 4-digit number, then that is becoming 3 times that 4-digit number. So it is exponential growth. Normally exponential growth happens by multiplying with something. But multiplying with something also, only 2 and 1 are present in all the numbers, and 3 also. So that also is very rare to happen like that. So it is not any of our normal sequences, it is something else. It depends upon the cardinality and ordinality of the numbers. We can say because numbers there are 3 uses. Cardinality, as cardinal numbers we use, ordinal numbers we use, and as symbols also numbers are used. In this 2 of these properties we are using cardinality. That means cardinality means quantity, how many are there. Ordinality means the position. And numbers can also be used as symbols also. Just symbol 1, symbol 2, without any meaning also you can use. So here symbol property of numbers also, cardinal property of numbers also, both are used to define the sequence. Listen very carefully. How you read a mobile number, that is the way we can say it is see and tell sequence. For example, if you see a mobile number, fancy number like this, 99977665555. Normally we read this like this, 999776655. That triple double usage, I think all of you noted. That is actually the quantity we are saying. How many 9s are there in a group? How many 7s are there in a group? How many 6 are there in a group? How many 5s are there in a group? So 3 times 9 are there, 2 times 7 are there, 2 times 6 are there, 3 times 5 are there, and this is called see and tell sequence logic. See the sequence and tell the sequence just like you dictate a mobile number. But in mobile number what happens is, when there is only one time we will not say it is single one, but in see and tell sequence you have to say that also, because you are seeing the sequence and telling the sequence. If you want to clearly mention to a person what is the number and OTP, if an OTP is like this, 22133, you will say 22, then A1, then A1 means then 11, then 2 3s, then 2 3s are there, then A4, then A4 means then 14. That means we can say this is 22112314. That is the idea of see and tell sequence. Now with this example you will understand, I guess. First number is symbol 2. How many times symbol 2? 1 times the symbol 2. 1, 2. So if this was a mobile number, a single digit mobile number, we can say this is 1, 2 only. 1, 2, how you write it in digits? Quantity 1, 1, symbol 2, 1, 2. That is the next term 1, 2. How many times a symbol 2 are there? 1 times a symbol 2 are there. That is the next term. Now from that 1, 2 use the same logic. 1, 2 is what? There are two things here. If this is a mobile number, you will say there is a 1, there is 1, 1. There is a 2, there is 1, 2. That means this is 1, 1, 1, 2. 1, 1, 1, 2 will be the next term. And look at this. This is the next term 1, 1, 1, 2. I hope all of you are understanding what I am saying. In series formation, this is one of the tricky sequence. Once you understood the sequence, this is very simple a sequence. 111, 1, 2. That is the next term, because this is 3, 1, 3 times a symbol 1, then 1 times a symbol 2. 3, 1, 1, 2. Then write it out. See the sequence, tell the sequence, write the sequence. That's the next one. 3, 1, 1, 2. That is the next term. So we understood the rule. If you understood the rule, find the next term. Post it in the chat. What is the answer you got? 3, 1, 1, 2. What is the next term? Here there are 3 groups of things. There is a 3. There is 1, 3. There is double 1. 2, 1. 2 times a symbol 1. And there is a 2. There is a 2 means 1, 2 is there. 1, 3, 2, 1, 1, 2. 1, 3, 2, 1, 1, 2. 1, 3, 2, 1, 1, 2 will be the next term. 1, 3, 2, 1, 1, 2. I think all of you understood this now. I will explain briefly one more time. This is a 2, that is 1, 2. That is why we are saying 1, 2. Write it down 1, 2. Just listen to what I am saying. Listen to what you are reading here. What is this? A 2, 1, 2. Write it down 1, 2. And what is this? 1, 1 is there. 1, 1, write it down. 1, 2 is there. Write it down 1, 2. So from that you have to find the next term. 1, 1, 1, 2 is the next term. 1, 1, 1, 2. How many 1s are there? 3 1s are there. Write it down. How many 2s are there? 1 2s are there. Write it down. That is the next term. 3, 1, 1, 2. Now there are 3 groups of things. 3 groups of things. There is a 3. 1, 3 is there. There is 2 1s. Double 1 is there. There is 1 2. 1 2 is there. 3 1 3 2 1 1 2 will be the next term. So if the question is asking what is the next term in the sequence, 1 3 2 1 1 2 will be the answer. I will show you a question which was asking the same idea, and there, for your information, they have given the name of the sequence also, see and tell sequence. So it was a problem which came in December 2012 NET exam. All of you try this now. Now it should be very simple. All of you try it and find the next term. First number gives you second number, second gives you third, third gives you fourth, and so on. How? If this is a number, you will say this is 1. How many ones? A 1, single one, that is 1 1, 1 1, that is the next term. Now from 1 1, what is this? 2 ones are there. How many ones? 2 ones are there. Double 1, that is 2 1, that is the next term. Now what all are here? There is a 2, 1 2 is there, there is a 1, 1 1 is there, 1 2 1 1, that is the next term. 1 2 1 1. Now same idea, 1 2 1 1, is it giving you the next term? That is what we are checking. 1 1 is there, there is a 1, you are seeing that, that is 1 1. Then 1 2 is there, that is 1 2. Then 2 1 is there, double 1, 2 1, 1 1 1 2 2 1. So we understood that also. Then find the missing term by the same idea. What is the idea? Ones are there. How many in number? 3 ones are there. 3 times ones are there. 2s are there. How many in number? 2 2s are there. Ones are there. How many in number? 1 1. 3 1 2 2 1 1 will be the next term. That is why option A is the answer. Option A was the answer. Without understanding this logic, this question to be done at the time of exam, it is very challenging. That is why I am saying try to learn some standard logic, so that if question comes from that logic, it will be very simple to do. Now 3 1 2 2 1 1, if you want to find even, you can find the next term also. 3 1 2 2 1 1. 3 1 2 2 1 1 means 1 3 is there, then 1 1 is there, 2 2 is there, 2 1 is there. That will be the next term. And if you are feeling bored any time, you can continue this sequence up to eternity. It will never end. And the next level of learning the sequences, try to create your own example. I think now you are able to do your own example. Okay, anyone need more explanation? This is what I told. From first term, this is 1 1. 1 1, when you write it in digits, you write like this. That is the next term 1 1. Now 1 1, you are thinking 1 1, 2 ones are there. 2 ones means 2 times 1. That is the next term 2 1. Now 2 1, there are two groups of things. 1 2 is there, 1 1 is there. 1 2 1 1. Now 1 2 1 1, three groups of things are there. 1 1, 1 2, 2 1. That is 1 1, 1 2, 2 1. Then by the same idea, 1 1 1, that is 3 ones. 2 2, that is 2 2. Then 1 1, that is 3 1 2 2 1 1. That is the answer. Now can you try creating your own example for a CSIR-NET sequence? Your own example for a CSIR-NET sequence. What you need for creating a CSIR-NET sequence? Just the first digit. CSIR-NET sequence is the most easiest example to create, because you don't need anything. Just take a random first digit, first number 3. Then from 3 you can form 1 3, because how many 3s are there? 1 3s are there. Then 1 1 1 3. Then 3 1 1 3. Then 1 3 2 1 1 3, and so on. That will be an example. If you start with 4, another example originates. 4 1 4, 1 1 1 4, 3 1 1 4, 1 3 2 1 1 4, and so on. So that is how CSIR-NET sequence. Any number of examples you can create your own. So I think you have understood CSIR-NET sequence also. Now I will just summarize what techniques you can use to identify sequence. Okay, I will give you one example for Fibonacci also, then we will go to that topic. Try this question. Yeah, when I told the clue, I think it is very obvious now. All of you try it. This is another previous NET exam problem. Number of circles is following a pattern. Let's analyze what? 1 circle, 1 circle, 2 circle, 3 circle, 5 circles, 8 circle. 1 1 2 1 1 2 3 5 8. What is the next two terms? Question mark is denoting the number of circles. So it is very obvious. 1. So anyway, this is 1 circle, 2 circle, 3 circle, 5 circle, 8 circle. What is that? 1 1 2 3 5 8. Next term you have to find. That is clearly a Fibonacci sequence. I have explained in detail what is Fibonacci sequence. First two terms should be 1, next term should be sum of the previous terms. So 2 will be 1 plus 1. This 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, and 8 plus 13 is 21. So the next two terms is asked. So option C, 13 and 21 will be the answer. 13 circles here, 21 circles here. If you want to find one more term, 34 will be the next term, and so on. I think that is obvious to all of you. It is clear to all of you, I guess. So option C was the answer for that question. Now I will just summarize what all are the different methods or what all are the different techniques you can use to identify a standard sequence. Listen very carefully. The first technique you can see, because as I told, the main problem is at the time of exam you don't have any idea what sequence is given to you. So tips, I can say the tips you can use for identifying a sequence. First tip is take the difference and check. Take the difference and check. Difference itself will give you idea about many of the sequence. Difference will directly give you the idea about arithmetic sequence. It will also give you idea about two-tier sequence. It will also give you idea about prime sequence, because prime sequence the difference will be in a small region like 2, 4, 6 range normally, because below 100 almost all the difference are 2, 4, 6 range. So when you see that a sequence difference is following like 2, 4, 6 and it is not any other sequence, you can doubt it can be a prime sequence, because this is 6 difference, this is 2 difference, this is 6 difference, this is 4 difference, and so on. Difference taking is one sequence, one technique, and second technique is reversing the digits. You will get an idea whether it is reversal sequence. But before that, irregularity checking. Checking the irregularity is one technique. Checking the irregularity means whether the numbers are going up and down or not. Numbers will go up and down normally in two sequences. One is twin sequence, another is twin sequence, and another sequence is reversal sequence. Numbers can jump up and down. 16 is jumping down, 16 is coming down to 11, then going up to 25, then down, then up, then down, then up. Up and down will happen normally in a twin sequence or sometimes in a reversal sequence also. Look at this, 63 increasing to 94, then decreasing, then decreasing. So up and down, numbers are jumping up and down. That normally happens in reversal or twin sequence only. Other sequence, it will be either strictly increasing or it will be strictly decreasing. I will give you printed materials itself tomorrow. I mean not printed materials. I will give you in the slides itself. I will explain these techniques in detail. Difference, irregularity, and more techniques we will discuss tomorrow. I think the theory part we will conclude here. When you discuss more previous year questions, I will show you more techniques to identify them.